Hello, Water Managers. I am Alex Davis. I am with the Water Management Systems Division out at the Hydraulic Engineering Center. In this video, I will cover real-time hydraulic modeling forecasting tools. The main objectives of this lesson is to learn about what forecasting options are available in the CAVI for hydraulic modeling, i.e. HEC-HMS. Then we'll discuss how to effectively calibrate an HMS model. So this is over a 3-series video. The first 2 videos are on the model calibration and then forecast specific editors. And then this one's going to focus on the HEC-HMS CAVI integration. And so just tools that we have built into the CAVI that use HMS processes. So let's get started. So here's the CAVI with a focus on the HMS options. We are currently in a forecast alternative noted by being in the modeling tab and then having a name in the forecast tree. So up here we're in the modeling tab, we have forecast name and we have this populated. In the top we have the icons of the application within SWMS. Each of these will take you to their respective applications. So we're focusing on HMS. So up here we have the HMS icon. If we click on that, we would open up the HMS user interface and be able to poke around in that. Then on the left, we have the forecast, and then we could left click on this HMS one, and then we get this these actions available to us. And so these are the features that we believe are going to be most applicable for real-time modeling. And so we have these quick action buttons that you can go through to do your calibration. One thing of note is that running HMS from the CAVI versus an HMS editor is that the data might be saved to the HMS project DSS versus the forecast DSS. If you aren't aware, the forecast.dss is where a CAVI forecast holds all of the data needed to it. So if we don't have the data in the forecast.dss, the CAVI doesn't really see that it's there. This is going to be changed in an upcoming release of HMS, and all of the data that's computed in an HMS forecast within the CAVI is going to be saved to the forecast.dss. So ideally this won't be an issue, a potential issue for much longer. And then right out of frame at the bottom we have force compute. And so this is going to force a recompute of the model, no matter if you made a change or not. So the CAVI and then the applications are smart enough to see like, oh, there was no change made. We don't need to recompute it. The CAVI message just says like skipped. And so a lot of the times in this case, we have METView feeding into HMS, and we're not going to modify METView very much. And so we're not going to rerun METView every time we want to run HMS during the calibration process. And so the CAVI is not going to do it by default. So if we do the force recompute and then we select the forecast and we hit compute from there, it would recompute the METView alternative each time we do that. And so from here we have all these buttons that we believe are all you need for doing a calibration most of the time. But the main one we're interested in is this combined parameter editor. The combined parameter editor is where we believe that you can basically do the entire calibration from this one interface. So this slide represents what you might be looking at when you're doing a calibration. So on the top we have 2 graphics, one for a gauge location and one for a reservoir. And so we can see how we're doing. And then to the right we have the summary table, so we can see how we're doing statistically. And then in the bottom, this is our combined parameter editor. So along the top are various items that we might need to calibrate. And so right now we're looking at reservoirs. So we can see that we have our method to replace all with zeros for a reservoir for discharge after our forecast time. And we haven't set up any stage data for this to start with. But then without having to go to a different interface, we can go over here to deficit constant loss, and we can start calibrating that without having to go and click a different button somewhere else in the interface of the CAVI or going through HMS. And then down here, we still have that compute to point option. And so in this case, I know that this gauge location is just upstream of this reservoir location, and they're both at the headwater of our project, of our basin model. And so down here, we're using this computational point to do just to Coyote, which is our reservoir. And so this is just going to do the headwater to this model. And so we're going to be running like 3 or 4 subbasins versus 30 or however many are in this entire basin model. So this is just another time save and ideally a way that we can go through this calibration process. So we've talked a lot about HMS and getting to its interfaces, but how do we actually see this in the CAVI? So here's an example of what we might see in the CAVI, just this portion right here. And we'll notice we see some familiar icons. So we can see that there's the subbasin icons from the CAVI, from HMS in the CAVI. And then we can see it's connected to the red dots, and the red dots are going to be the junctions, so not quite following the HMS notation in this case. But then the junctions are most likely going to have multiple models looking at it. And so if we were to click on it and we would right click, that's how we interact with stuff in the CAVI, we'll probably get an options for ResSim and HMS, and then we can choose which ones that we want to look at. When we click on, let's say, this subbasin icon, you would right click on it, and then you'd get various options to do straight out of the CAVI interface. So we could edit the parameters. So that's what's showing up on the left side if we wanted to. And then we also get options for viewing the graphs, to see the graphs, the time series table, or to see the summary table. So we can see generally what we need to see for the calibration process from the CAVI and not have to go to the HMS application itself. But then with this, we're also following a different process in the data stream. So we had METView feeding data directly into HMS as a boundary condition. We set this up in the model linking of the CAVI. So in here, we have our forecast run name. Then we have our model. So we're looking at our HMS model. So and then we can see that we're looking at location of NBM parameter, we're looking at precipitation, and then we're looking at what we're inputting from. So our precipitation, our boundary condition in this case, is coming from METView. It's coming from the output of QPF NBM from METView. That's the name of the model. And then we have this location parameter. And so this is just the model output from METView. And then if you hover over it, you can see the full path name of it. And so we can do that. And then for the observed flow, stage, and sweep, these are going to come from extract lists. And so the extract list is just it's going to pull data from our forecast.dss and put it in the model to be used for the observed data. One thing to keep in mind is that in this setup, so we're using CAVI for forecasting, it's going to overwrite any paths that are in HMS that's also in this model linking. And so if we have a Coyote inflow marked as a specific path in HMS, it doesn't care. It's going to use what we have set over here as this Russian Coyote flow in, etc. And so changing those path names in HMS isn't going to matter when it comes to this model linking in the CAVI. If you want to change what the path name is that we're wanting to link, you need to do it from the model linking in the CAVI. And then one other thing of interest for the real-time modeling is noting the difference between subbasin flow and flow local. This is an option that can be selected in the basin model. So we can see here we have local flow. When we turn this to yes, we haven't saved it yet because it's blue, but we changed it to yes. And so this lets you, this is differentiated by various things in that, let's say we have flow local on, we look at the flow local here at junction 1, it's just going to take into account the flow coming into the junction from the subbasins and not from the reach. And so if we did flow at junction 1, it would be the flow coming from anywhere upstream, so in this case subbasin 1, getting routed through reach 1, and then subbasins 2, 3, and 4. If we look at flow local, it will just be the flow coming in from subbasins 2, 3, and 4. So it's not going to have the flow coming in from the routing reach. While if we look at junction 2, the sub-basin flow, since it's the only one sub-basin coming into this junction, the sub-basin flow of sub-basin 5 is going to be the same as the flow local of junction 2, because all the other flows upstream of it are coming in through this reach and not directly routed to this junction. And so flow local can be something that's toggled on and off at the discretion of the modeler, just kind of a user preference and what you're looking for. And so that wraps up this series on this topic. If you have any questions about our software, need some help, or are looking for additional training, check out these links. They can also be found in the description below. Appreciate your time and hope you have a fantastic day. Bye-bye.